Hello everyone, in this video I provide an introduction to FPGA coding. I explain how to implement a simple digital logic that will turn on an LED if switch 1 and switch 2 are pressed. So let's illustrate that. Now switch 1 is pressed, nothing happens, and when I press the switch 1 we can see that the LED over here is on. Now the switch 1 is in its original position and you can see that LED is off. So from the Boolean logic's point of view, LED 1 is equal to switch 1 logical AND switch 2. In addition to this logical statement over here, I will add another part that will turn on another LED if switch 3 is pressed. So here's my switch 3 and you can see that another LED is on. And let's turn on all the LEDs. Here switch 1 is pressed, switch 2 is pressed, and switch 3 is pressed. Before I start with coding, I have to make a few remarks. First of all, I'm using the Nexus A7 FPGA. However, everything that I will explain in this video can be generalized to any other FPGA as long as you have the schematics of that FPGA. Then let me please explain the main motivation for creating this video tutorial. Namely, it is true that online you can find a number of posts and tons of YouTube tutorials on FPGA coding. However, my experience is that these tutorials are often lacking critical implementation details, and for students and engineers who are not experienced with FPGAs, it might be difficult to follow these tutorials. On contrary, in this video tutorial, I will provide a step-by-step procedure for coding FPGA boards. That is, I will explain you how to code an FPGA from scratch. Also, it took me a significant amount of time to create this video. Consequently, I would appreciate if you could press the like and subscribe buttons. Thank you very much. I will be using the Vivado programming environment and the Verilog programming language. The Verilog programming language is a widely used hardware description language for coding FPGAs. Okay, so let's start with implementation. As you can see, I'm using the Vivado programming environment. I'm clicking on Create Project, then I click on Next. Here I will use the default settings, I click on Next, and here I will just use the RTL project, go Next. I will not add sources and I'm not going to add constraints. I will explain later what are the sources and constraints, so don't worry about it. We click on Next. And over here it's very crucial that you properly select your part number, that is default part or the board. Now, one approach is to look into your FPGA board and to look into the number written on your processor. And that number should match the part number that you can see over here. Another approach that's arguably more easier is to type your board number or your board name. In my case, it's Nexus, and this is Nexus A7-100T. And then you can click on Next. Here I have to mention the following. When I first installed Vivado, I could not find this board. So first of all, I had to click on Refresh, and then after that, I need to click on this download button in order to download my board. So if you're experiencing this issue, that is, if you don't see your board, you need to refresh and then click on download button. So now my board is selected, I can click on Next. And here you can see the summary and click on Finish. And after some waiting and updating, you can see the Vivado programming environment. Before we proceed with the implementation, it is always a good idea to draw a logical diagram of our code. So what you can see over here is the logical representation of the code that we need to implement. Switch 1, switch 2, and switch 3 are the inputs, and LED 1 and LED 2 are the outputs. This half circle is a graphical representation or a symbol for the logical AND. And LED 1 is equal switch 1 and switch 2. This is a Boolean equation representing the first part of our code. Then LED 2 is simply equal to switch 2. And here I only have 1. Okay, so let's see how to implement this logical circuit. First I will click on Add Sources, and here I have 3 options. The first option is to add or create constraints. I will explain this option later in this video. The second option is the option that we are going to choose. This is the option Add or Create Design Sources. And the third option I will not use in this video. I click on Next. Here I click on plus button and I click on Create a File. And the file name will be constraint1. And I click on OK. And I click on Finish. Here I will click on Cancel and Yes. To edit the source code, we will click over here and we will double click on constraint1.v. And over here we need to define our logics. Basically, we need to define a module. So what is a module? A module is basically a function that takes inputs and outputs and defines your logics. So let us write module circuit 1, and here we need to end with a semicolon, the statement, and we need to end the module. So this is our module. Here we need to specify inputs and outputs. To specify inputs and outputs, we need to look again into our schematics. So we can see that inputs are switch 1, switch 2, switch 3, and the outputs are LED 1 and LED 2. So let us specify these inputs and outputs. So we will write input switch 1, then another input is switch 2, another input is switch 3, and output is LED 1 and another output is LED 2. Great. So this is our module or function that defines our logics. We have switch 1, switch 2, and switch 3 as inputs, and we have 2 outputs, LED 1 and LED 2. The next step is to define our AND circuit or AND gate. Basically in Verilog, we can use the AND statement to define the AND circuit or the AND gate. The first argument is the output. In our case, the output is LED 1, and the second and third arguments are the inputs. In our case, the inputs are switch 1 and switch 2. And don't forget to end this code line with a semicolon. Now, as a side comment, I will explain you how to write comments in Verilog. Basically, you can use this symbol, and it's always a good idea to write a logical explanation or basically Boolean equation describing this circuit. Okay, the next step is basically to assign switch 2, or actually switch 3 to LED 2. We can use that by using the statement assign, and then we can write LED 2 is equal to switch 3 and semicolon. So this code line will ensure that whenever switch 3 is pressed, that LED 2 is on. And the first code line will ensure that when switch 1 and switch 2 are pressed, then LED 1 is on. And that's it. That's our logics. And don't forget to press Ctrl S. However, this is not the whole story. We have just defined the circuit. However, we did not connect switch 1, switch 2, switch 3, LED 1 and LED 2 with the physical ports and physical switches and LEDs on our board. So we need to define another file, and that file is called a constraint file. And as the name suggests, the constraint file will constrain switch 1, switch 2, switch 3, LED 1, LED 2 to push button or switches and LEDs on our board. So let's define a constraint file. So I click on Add Sources, and then I click over here. That is, I select the first option, Add or Create Constraints. I click on Next. And here I click on plus sign and I click on Create File. And let's give the name to this file. Let's call it constraint 1. And let's click on OK. And then let's click on Finish. Okay, so let's find our constraint file. Basically, over here I have my constraint file. Notice the extension of the constraint file, it's HDC. So let's double click on this file, and over here we need to write a code. Believe it or not, to write a constraint file, we will use only a single keyword or a function that's called setProperty. And my advice is always to read the tutorial or read the manual of certain function. Don't just copy and paste the code lines that you find online. That's really a bad practice. So here you can see a page from the manual that nicely explains the set property. This is a very clear explanation written by Xilinx and AMD. I will basically provide a link to this page in the description below. So here is the usage, and what is important is that this basically keyword or function assigns the defined property name and value to the specified objects. In our case, the objects are basically ports corresponding to switch 1, switch 2, switch 3, LED 1 and LED 2. To physically assign a physical push button on your board to switch 1, we need to write these two code lines. So we use the set property. The name is IO standard. The value is this abbreviation, and the object is defined by this part over here in square brackets. So these square brackets will basically correspond to the value returned to get ports. So we are saying get ports switch 1, that is get object, and this will correspond to the get port switch 1. So the object will be this, the value will be this, and the name is this thing. So this is the first code line. However, we need the second code line. And again, set property, the name is package pin, the value here we need to find, and again, the object is returned by get port switch 1. Now here we have 1 degree of freedom. We can freely choose the physical button or push button on our board that corresponds to switch 1. Now, in my case, I chose the first push button from the right. You can also watch the beginning of the video for the demonstration. We need to find the value or the name of the first push button from the right side, and we need to enter it over here. Now, how to find this value? Well, we need to look into the schematics of our board. In my case, I'm using Nexus A7 board, and after some Googling and search, I found this page. And if you scroll down, you can find important documents over here. We need schematics and reference manual. In your case, you will need to search for schematics of your board. However, these schematics are basically posted online and you can freely find them. So let's look into the schematics of our board and the reference manual. So I click over here on the reference manual, and this is the reference manual of my board. This is basically an image with all the components and explanations. I don't need that, so I will scroll down to the page 16, and on the page 16 I can find the schematics. So this is my first button from the right side. This is the second and third. So this will be switch 1, switch 2, and switch 3. And here are the values. The values are J15, L16, and M13. Now, there is another way, and that's more complicated way to find these values. I can click over here to obtain a more detailed schematics, and then you need to scroll down to search for a switch. However, from this diagram, we can see that the switch we are searching for is SW0, so we can simply go here and do Control F and search for SW0, and if we go down, we can find basically the description over here. Here's bank 15, and here is the value. Basically, this is the port value, it's J15, and it perfectly matches with the data that we see over here. So over here, I will write J15, and I need to repeat this procedure for switch 2 and switch 3. So I will copy and paste this code. Over here I will enter switch 2, here I will enter switch 3, and here I need to adjust the values. So I will just keep XXX here, XXX. So let's look into our schematics again. So here's our schematics. We can see that the switch 2 is at the value L16 and switch 3 is at M13. So I need to write L16 and M13. So again, this is very important step, L16, and here it should be L16, 16, and M13. Okay, that's it. We completed the assignment of switch 1, switch 2, and switch 3 to the physical push buttons. The next step is to connect the objects LED1 and LED2 with physical LEDs on our board. To do so, we need to look into the schematics. So here's our schematics, and if you remember the beginning of this video, my LED number 5 from the right is on when both switches are on, and LED basically 6 from the right side is on when switch 3 is on. So I need the LED number 5, that's 1, 2, 3, 4, 5, and this will be LED 1. So the number is R18, and I need to enter this value. So I go back to my code, I copy and paste these 2 lines of code, then I fix this part over here, I type LED 1, and over here I type LED 1, and notice here that the syntax is almost the same except basically these values. So LED 1 will be basically connected with R18. So I need to write R18 over here, and I need to repeat this procedure for LED2. This is my LED2, LED2, and here I need to enter the proper value. Here's my schematics, and it's V17. So I need to enter here V17. And that's basically it. Don't forget to save this file. And that's basically it. We have our source file defining the logics, and we have our constraint file defining all the connections. And the next step is to run synthesis. So I need to click over here, and here basically I can adjust some parameters. I don't want to play with these parameters. I can just simply click OK. And over here you can see the progress status. So you can see that something is happening. Over here the synthesis is running, and you need to wait for at least maybe 1 minute for this process to complete. After the process is completed, you will get this window, and we need to run implementation However, I will manually run the implementation because I want to investigate what actually happened. So here you can click on Open Synthesize Design, and you have here information, but very useful information is schematics of this circuit. So if you click over here, you will see the schematics of the circuit, and it's always good to check the schematics. So this is the schematics. I have switch 1 basically, and then I have switch 2. They go into this AND gate, and then they're assigned to LED 1. Similarly, switch 3 is automatically assigned to LED 2. So this is our schematics. Now, we need to click on Run Implementation, and we click on OK. And then here you can basically track the log, you can track reports, you can see everything what's happening. Now the implementation step is running. You can double click again to see that it's running. You can just close this window. After the process is completed, you will get this screen, and the next step is generate the bit stream. You can simply click here and OK. However, I will do it manually. And here you can click on generate the bit stream and you click OK. And again, this step will take maybe a minute or so depending on your computer. How fast is your computer? And if there are no errors, you should get this screen. So the bit stream generation completed. There are no errors, probably there might be some warnings. However, we are going to ignore this. Okay, then I will click on cancel over here. Now, the final step is basically to connect the hardware and to upload your code or the bit stream. So you open the hardware manager over here and you don't see anything over here. And what you can see over here, no hardware target is open. So what you need to do, you need to connect your FPGA board to your computer through USB port. So you use the UART connection, you connect one part to your FPGA, another part to your PC or laptop computer, and once you do that, you can click over here on Open Target and Auto Connect. And then you need to wait for some time. You'll see messages over here, connecting to server, and over here you can see that something changed. Here, it's very important to analyze what's happening. You have that your local host is connected. That's basically you're connected to your FPGA. And it's written over here that this basically system is open and this particular processor or the board or whatever it is programmed. However, this is probably an old program, so you need to override it. So you do the right click and you click on Program Device, and then you click on Program. And then Programming Device is completed. Now everything is done. The code is uploaded on your FPGA, and you can test your code basically by pressing switch 1, switch 2 at the same time. The LED should turn on, and then switch 3, when the switch 3 is pressed, the LED should be turned on, the corresponding LED. Okay, that will be all for today. I hope that you like this video. If you like the videos I create, please press the like button and subscribe button, and moreover support this channel. Thank you very much and have a nice day.